13. Arrangement of parallel conductors described in this thing. I'm going to try to find point P. These are point 2. They give me a distance. Point P is located in the magnetic field 0.5 centimeters from the to the left. Oh, the left of the. Okay, so this is 0.5, 0.05, right? This is 0.2, and then this is still our 10, and this is still 15, right? Nope, I got the backward. Nope, that's right. Okay, so we're in the magnetic field there. So the first thing I'm going to do is I'm going to figure out the magnetic field this one causes. How do we figure that out? Integral of B dot dl equals mu naught I. Mu naught I is therefore equal to B times 2 pi r. Agreed? Therefore, 4 pi times 10 to the negative 7th times the current, which is 10, divided by 2 pi. The new radius would be 0.15. Will be the magnetic field that one causes. Agreed? I'm not seeing a lot of nodding of heads, but there's only 4 people in the room. That might be the problem. Are we good? Okay, so I'm going to simply divide that out. I get 2, I get 20. Oh, I can't do that in my head. What do we get for the answer? We got it? Times 10 to the negative 5th. Teslas, right? Okay, so let's do the second one. Let's do the same thing for the second wire, right? So I'm going to do the exact same thing. I get mu naught I equals B times 2 pi r. Mu naught is 4 pi times 10 to the negative 7th. Current is 15 for this wire. B over 2 pi, and the distance here would be 0.05. Agreed? Connor with me? What's my answer for that one then?
Well, I got 6 times 10 to the negative 5th.
6 times 10 to the negative 5th Teslas. You may disagree with that before we continue our conversation. Okay, now, how do I... Well,
wouldn't you only have to do the second one because it says 5 centimeters to the left? Oh, wait.
but is the other one causing a magnetic field?
You have to, okay, so you have to do both.
And then what am I going to do with them? Which is what the question I was waiting for somebody to ask me. What?
What's the direction?
I need a direction, and I need to know, do I add them or not? Is it okay to add magnetic fields? The answer is yes. They're great forces, right? So therefore, we know we can add forces, so therefore we can add magnetic fields. Now the question is, do we add them or subtract them? Which way are they going? So I grab my right hand, and I coil it around, and I go, whoops, wrong way, because the currents are going this way, right? So I'm going to go this way, so the one on the left comes out of the board. Great.
Yeah.
And this one here goes into the board. So I'm going to add or subtract them. I'm going to subtract them. So I'm going to do 6 times 10 to the negative 5th minus 1.33 times 10 to the negative 5th. And I would get 4.6, probably 6.6, but I'll go 6.7 times 10 to the negative 5th Teslas. And what's the direction?
Into the paper.
Into the paper.
Wait, which one's in and which one's out?
Okay, right hand. Coil around this one.
No, which, like the X or the dot?
X is in. That's the dart.
X.
And dart coming at your forehead is out. Picture a dart. If you see the back of the dart, it's going in. You see the front of the dart, it's coming at your forehead.
All right.
Okay? So into the board. Agreed? Bien? Make sense? All right. All right, we're doing okay. All right, try number 17. These are actually usually easier when you start talking about coils because they're simplifying things best they can. Get that BS is equal to mu naught I think they use N, whatever it is they use, please fix it if it's not that. N is our turns per unit length. So I get that if my magnetic field is 8 times 10 to the negative 5th, my mu naught is 4 pi times 10 to the negative 7th. And then I've got 0.5 is my current. I want to know my turns per unit length. So I can solve this directly. I get 8, 8 cancels out. I get something awful like 1 over pi times 10 to the second. So let's just put that in our calculators for physics students, not mathematicians. So I got 8 exponent negative 5 divided by 4 divided by pi divided by, divided by 1 exponent negative 7 divided by 0.5. What do I get? 318? That feels wrong. I thought I was going to get less than that. Okay, then somebody fix this. What did I do wrong? 8 times 10 to the negative 5th divided by 4 divided by pi.
I got 127.
Divided by 0.2. Where did I get the divided by 0.2? That's just dumber than a rock. Okay. 63.66 divided by 0.5 would be correct. How about 127? What you guys got? So I got 127 is my turns per length. They gave us the length. What's the length? 0.25. So how many turns do I have?
Um,
127 is equal to turns per unit length. So 127 times 0.25 gives me 31.8-ish. I'm probably rounding the heck out of the way from the answer. That's how many turns I would have. Make sense?
Yeah.
Can do? All right. Only one more thing to play with. Ready for your punchline? Woo! Stand up, sit down. I'll start in a minute. It's going to be awful. The most useful thing, though. It's the most useful thing we're going to do.